Hey there, I'm going to show you how to create a sketch of the box problem that we talked about in class today. If you actually go to today's outline and click on GeoGebraTube version, you'll see the goal of what we're going to create. We're going to create a sketch that looks something like this. You'll notice over here to the left there's a box with the corners cut out. We drag on the slider and it changes the size of the cutouts. Notice that when I change those sizes, the height of the box changes, as well as this graph that plots the volume of the box with respect to the dimensions of the cutout. You'll notice as I drag on this, the point that's traced along that curve changes. It shows the volume for a particular cutout size. So let's go ahead and begin. I'll refer back to this when I need to in case I forget what I'm doing. If I go back to GeoGebra, the first thing that I want to do, I'm going to turn off all my labeling. I'm going to turn up the font size a little bit so it's easier to see. And we're going to begin by creating a model of the paper that we're going to cut. So to do that, I'm going to first create a point at the origin, and then I'm going to construct some rays off of that origin on first the y-axis, then another one on the x-axis. And these are going to represent two edges of my paper. Once I have those created, I can hide the x and y axes. Now, novice sketchers might want to use these points as points, the corners of my paper, but I don't want to do that because you'll notice we could have negative paper that way. I don't want to do that. So let's go ahead and hide these points, point B and point C. We're going to make new points that represent the corners of the paper. Notice that when I drag these, they won't go below. They're stuck to that ray. Same with this. And now to create the final corner point, I'm going to use the perpendicular line tool and create perpendiculars to each edge of the paper. Where they intersect will be my final vertex. Let's see if I got that one right. I'm not sure I did. No, I didn't. So let's delete that. Let's try again. I want to make sure that that point is at the intersection. In fact, that one is, I can tell already. See, it's not draggable. Once we have the paper, I want to hide these lines. I'm going to click on the lines and then right click and unshow objects. I also don't need to see the rays anymore, so I'm going to hide those as well. And then let's connect these four corners of the paper with a polygon. So I have my paper. What I don't have are the corners cut out, so I need to think about this a little bit. Turns out that the size of the cutout, the square, it's going to have a side length that's no longer than half of the length of the smaller side of the piece of paper. So we can set up I'm going to set up a variable here that describes the length of the shorter side of the piece of paper. You'll notice that this side of the paper is called D, and this side's called A. I'm going to rename those. I think I want to call A, rename it as how about width, and then let's call D the height. I just think that's easier to keep track of, and I don't need these labels. Let's unshow the label. Okay, so I got my width and my height. I'm going to call, I'm going to create a new variable called max cutout. That'll be the maximum length of the cutout square. And let's let that be, it'll be the minimum of height and width divided by 2. Because we're going to go at most halfway across with the square. There's a square on each side. There's going to be a square coming from over here. It can only go halfway. There's a square coming from here. It can't go past halfway. So we'll divide by 2. And if you recall from the sketch itself, we're controlling the length of the cutout from a slider. So this slider can go from 0 all the way up to half of the max cutout length. So that's exactly what we're going to do in the software. Let me go back to GeoGebra. We're going to create a slider. I'll just put it right here for now. And let's go ahead and call it, how about box height? Because that's what it is. And it's going to range from, how about 0 up to the name of that variable we called max cutout. I'm just going to type max cutout here. And we'll increment it by, how about 0.1? How about 0.01? Okay, are you with me? So now we have a slider that's going to control the cutout length, but we don't have a cutout. So the next step is to actually create squares that are cut out from each corner. And to create those, we're going to use a circle tool. I'm going to create a circle centered at the left bottom corner of the paper, and its radius is going to be box height. So notice, I kind of like to test things out as I build them. That circle never goes beyond halfway of the shorter side of the rectangle. If I were to drag this down, so that's the shorter side, notice that the circle never goes past the halfway point. And I can create, this is a circle, I actually want a square here, so I'm going to create intersections here of the circle and the rectangular paper. We already have 3 corners of the square right here, and they all move accordingly. The problem is I need the 4th vertex. So to create that, I'm going to use the perpendicular tool again. And let's create that intersection here for the 4th point. At this point, I can hide all these lines. I'm going to just click line and then right click, and I want to hide all of the lines. And let's create a polygon here. There's our square. And you can test it out by dragging on the slider. It appears to work. I'm going to be creatively lazy and create perpendicular bisectors each side of the paper. And then what we can do is use the reflection tool over here, reflect about line. I'm going to reflect this cutout across the different perpendicular bisectors. So now when I drag on the slider, you'll notice that all the cutouts move accordingly. So far so good. I want to hide these lines here. I can just click on those circles out to the side and that'll hide them. And then let's see. I have some extra points here that I don't need. Notice there's a bunch of reflected points. I noticed them down here because they have primes next to them. I'm just going to hide all those. There's more elegant ways to do this, but I'm just being quick. So now I have my paper back. I should be able to drag on this point. Why am I not able to do that? Let's think about that for a minute. That one works. Not sure why that one doesn't work. Let's see here. Definitely don't want those. Okay, I'm going to pause this for a minute. I'll be right back.